Why does time only flow in one direction? The relentless forward march of time is one of the most universal experiences of human existence. We are born, we age, we die. Cups shatter, but never unshatter. Memories accumulate, but the future remains unwritten. Why does time flow only in one direction, from past to future? This question, often called the arrow of time, sits at the crossroads of physics, philosophy, and human intuition, teasing the boundaries of what we believe is possible. As a philosopher and a scientist, let us embark on a journey through the empirical and the existential, weaving a narrative that keeps the mystery alive until the final word. The philosophical puzzle, time as a human construct. Philosophically, time is a slippery concept. Is it an objective feature of the universe, or a construct of the human mind? Immanuel Kant argued that time is a framework through which we perceive reality, a lens imposed by our consciousness. If time is a human invention, its one-way flow might reflect the limits of our perception rather than a cosmic truth. Yet, our experience of time's direction is inescapable. We cannot unremember events or live moments backward. This raises a profound question. Does time flow forward because of the universe's structure, or because of how we are wired to experience it? The philosopher Augustine of Hippo grappled with time's nature, famously confessing, "What then is time? If no one asks me, I know what it is. If I wish to explain it, I do not know." He suggested that time exists only in the present, with the past as memory and the future as anticipation. But why do these memories accrue in one direction? The philosophical intrigue lies in whether time's arrow is a property of the cosmos or a projection of our minds, a question that sets the stage for scientific exploration. The scientific anchor, the second law of thermodynamics. Physics provides a compelling explanation for time's arrow through the second law of thermodynamics, which states that entropy, the measure of disorder in a system, tends to increase over time. In a closed system, things move from order to chaos. A hot coffee cools, a tidy room becomes cluttered, a star burns out. This irreversible increase in entropy defines the thermodynamic arrow of time. The universe, born in a highly ordered state at the Big Bang, has been unwinding toward greater disorder ever since. Consider a classic example, a broken egg. Drop an egg, and it shatters, its contents spilling chaotically. You never see the yolk and shell spontaneously reassemble. This is entropy at work. Disorder increases, and the process is irreversible. The second law suggests that time's forward flow is tied to this universal tendency toward chaos. But why was the universe so ordered at the Big Bang? This low-entropy initial condition is a mystery, a clue that keeps the question of time's direction tantalizingly open. Alternative arrows, other perspectives on time's flow. While thermodynamics provides a robust explanation, other physical processes also define time's arrow. The cosmological arrow of time arises from the universe's expansion. Since the Big Bang, roughly 13.8 billion years ago, the universe has been expanding, a one-way process that aligns with our experience of time moving forward. If the universe were to contract, would time reverse? This speculative idea, while unlikely, adds intrigue to the puzzle. Another arrow is the psychological arrow of time, rooted in how we experience memory. We recall the past, but not the future, creating a subjective sense of time's direction. Neuroscientists link this to how our brains process information, forming memories as neural patterns that accumulate unidirectionally. But is this psychological arrow merely a reflection of the thermodynamic arrow, or something more fundamental? Quantum mechanics introduces further complexity. In quantum systems, many processes are time-reversible at the microscopic level. Particles interacting in a quantum field obey equations that work forward or backward in time. Yet, when we observe a quantum event, say, a particle decaying, it becomes irreversible, a phenomenon tied to the collapse of the quantum wave function. This quantum arrow of time suggests that observation itself may play a role in time's direction, blending physics with philosophical questions about consciousness. Speculative theories, challenging the one-way flow. Some physicists propose radical alternatives to explain time's arrow. The block universe theory, derived from Einstein's relativity, views time as a static dimension, like space. In this model, past, present, and future coexist, and the flow of time is an illusion created by our movement through this four-dimensional block. If true, why do we perceive time as flowing? This perspective, championed by physicists like Julian Barber, suggests that time's direction might be a subjective experience rather than an objective feature. Another provocative idea comes from loop quantum gravity, a theoretical framework attempting to unify quantum mechanics and general relativity. Some models suggest that the universe could have a bounce rather than a singular Big Bang, with a previous universe contracting to a point and then expanding into ours. In such a scenario, time's arrow might flip in the contracting phase, with entropy decreasing. Imagine a universe where eggs unbreak and coffee reheats. Could such a reality exist before ours? This keeps the mystery alive, pushing us to question whether time's direction is absolute. Philosophical reflections, time and meaning. Returning to philosophy, time's one-way flow shapes our understanding of existence. The irreversibility of time gives life its urgency. Moments pass, and we cannot reclaim them. Existentialists like Jean-Paul Sartre saw time's arrow as central to human freedom. We are condemned to choose in a forward-moving world, unable to undo our actions. This raises a deeper question. If time flowed backward, or not at all, would life lose its meaning? Consider a thought experiment. Imagine living in a universe where time flows backward. You'd undrink your coffee, unspeak your words, unlive your life. Would you still be you? The philosopher Derek Parfit argued that personal identity depends on the continuity of memory and experience, which time's arrow enables. Without it, our sense of self might dissolve, blending philosophy with the scientific question of why time moves forward. Intriguing examples: time in culture and experiment. Cultural narratives reflect our fascination with time's direction. In Greek mythology, Kronos, the god of time, devours his children, symbolizing time's relentless forward march. In contrast, some Eastern philosophies, like Hinduism, view time as cyclical, with universes rising and falling in endless cycles. These perspectives challenge the linear arrow of time, suggesting that our perception of its direction may be culturally shaped. Scientifically, experiments like those with kaon particles demonstrate time's asymmetry at the subatomic level. Kaons decay in ways that slightly favor one temporal direction, a phenomenon called CP violation. This hints that time's arrow may be woven into the universe's fundamental fabric beyond thermodynamics. Meanwhile, studies of black holes, where time and space behave strangely, suggest that near a singularity, time's flow might lose meaning. Could a mind near a black hole perceive time differently, blurring past and future? The mystery persists. Why forward? As we near the end, the question of why time flows in one direction remains tantalizingly unresolved. The second law of thermodynamics offers a compelling answer, tying time's arrow to entropy's rise. Yet, the low-entropy Big Bang, the block universe, and quantum mysteries keep the door open to speculation. Philosophically, time's direction shapes our existence, giving meaning to our choices and losses. Scientifically, it challenges us to unravel the universe's deepest laws. Picture a final analogy. Time is a river, flowing inexorably from source to sea. We ride its current, unable to swim upstream. Is the river's direction set by the universe's landscape, entropy, expansion, quantum laws? Or is it a trick of our perspective, a story we tell ourselves? Perhaps the answer lies not in pinning down time's arrow, but in embracing its mystery. As we probe deeper, with physics and philosophy as our guides, we are left to wonder, is time's one-way flow a cosmic rule, or a riddle we've yet to solve?